After removing the corrosion, painting a little primer and then some aluminum paint, I cleaned up each deck individually. Cleaned up the switch contacts with some deoxit, replaced capacitors and resistors, and now I'm getting ready to reassemble this whole thing. One thing I found I thought was kind of interesting was these guys. One capacitor here and one over here. So notice they have screws going through them. On the parts list, they refer to those as semi-fixed condenser 3500 microfarads or picofarads semi-fixed. There's two of them, and I measured them on the capacitance bridge, and they were off a little bit. 1650 was very close. I just tweaked it a little bit. 3500 was off by about 1000 picofarad. That's this bigger one, and I tweaked that until it was pretty much dead on. So hopefully I won't have to go in there and adjust those. There's plenty of trimmers for adjusting the rest of the settings. So notice there are nine coils, 9 trimmer caps, plus this extra one here. So they have a compensating cap for every one of these coils. For the antenna coils, the bandpass filters, and local oscillators. So I don't doubt that after I get this all together I'm going to have to go through and do the full alignment procedure. Alright, so getting this back together, I do believe that all these trimmers face down. So this is the top. And here's the 2 tube sockets. And I think this hole here is for the switch shaft to go through. So it's something like this. This wraps around the front. I'm going to put some screws in up here and some screws in here, but this doesn't want to go down. That's because I got some leads that I need to get through their appropriate holes. So get some wires sticking up on here, on here, on here. I think. Well, I know that some of these go to trimmer caps. I think these 2 capacitors got a trimmer cap, and this one does well, and then these 3, which is an odd thing about this design. I haven't quite figured out. I'm just going to go with it the way it was originally done. Is here are the gang trimmers. 1, 2, 3. Well, one side goes to tube elements, grid caps. Fine. It's the other side. They show grounded, 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 but also each one goes right to a capacitor. That is what these guys are all about. So here's the 3 caps, and then here are some of the leads that go to the capacitors or tube sockets. Actually, I think 2 of the capacitor go to the grid caps that go to the tops of the tubes, so there won't be any wires, and only one of them, I believe this is the one that connects directly to one of the trimmer cap sections, or tuning cap sections. So this is what I find confusing: is why are these here, and why they need to be grounded specifically to that point on the tuning capacitors. I would have thought that just tying these right to the chassis or something would be a good enough ground. Again, that goes back to what I was saying earlier about why are there various grounding lugs scattered around the chassis, and what should they be connected to, and how should they be interconnected. I still think it's because of the way this thing was designed with 3 separate chassis sections, and they wanted to make sure they had really good ground between them, but no ground loops and no oscillations. You gotta love reference photos. By referring to them, I know exactly how this goes back together. Tuning cap goes on like so. 2 screws up front hold it in place, and then there should be a rubber bushing back here. The original appears to be gone. I dug up one that's close but not quite right, but there is an exact reproduction made. I'll pick one up. Tube sockets went in like so. So the new ones will get wired up matching the orientation and the wiring on these, so I'm going to wire them up before I attach them here. So this is, I believe, is the green is the filament wire, And like these three are shorted together. That'd be the cathode and the shield and one side of the filament. And then I'll add on wires as needed, attach this capacitor, and get that wired up as much as I can. And including getting it wired into this. And then mount it up. So basically I won't need this for a while. I'm just going to be focusing on this and these two sockets. Some of the other socket wiring is these short wires that's going straight into these two sockets. And for the capacitor wiring, yeah, so these are the two grid caps. And so these are the three ground things they show in the schematic. So going right to metal, and this metal is attached to this metal through these screws, but even so they still have three more grounding connections here, and those go up into these three capacitors. And these ground straps here, I'm not entirely sure where they go. I think they might attach to the other sub-chassis assemblies to ground this firmly to those. Okay, I've got the sockets wired up as much as I think I can while they're not connected to anything else. So, bus wire, that's ground for the cathode, and the shield, depending on the type of tube plugged in, that's pin 1. It's not used in the G types, but it's used in the GT and the metal type. And also one side of the filament that will get tied to these terminals here and here. That'll be the final thing I do. And this thicker green wire here, that is, I believe, the AGC bus. Earlier in an earlier installment, I was wondering where the cap was for the AGC. Well, it's right there. Not sure why I didn't notice that earlier, but that is what this guy is. And then this is the other side of the filament supply. So these need to get flipped around. They mount down around like so. And I'm pretty sure the side of the cap connects to that terminal down there. This guy will go in about up here, and that just leaves figuring out where these few wires go. These I know go to the tuning cap. These I believe go to the tubes. I went ahead and looked up the tubes and wrote in the pin numbers. It'll be invaluable to figuring this out. Oh, and I did check all the coils for continuity, and they all seem to be fine, so I think we're all right there. Oh, and I also got some tubes. This guy's selling tubes really cheap on eBay. I think he was selling like 6 Q7s for $1 a piece, new old stock Raytheon, so I picked up some of these. And although the originals were G-types, I actually like these better. Because they have a built-in shield. These Philco shields, aside from it being a bit dingy, they actually don't really fit over the tubes very well. I'll pull out a G-type tube and show you what I mean. So here's a 6A8G. They call it a detector oscillator. In my mind, it's an oscillator mixer tube. And here is one of the shields, and as you can see, it doesn't fit too well. Round peg into a square hole situation. But that's what they originally used. These are all G-types, so what you do is you just shove it on over there, get it down in there, and it just gets bulged and kind of knocked out of round. And then here's the base, which is square, and that you got to shove on there pretty good, and that kind of re-squares up the base, puts a lot of pressure on it, and it's bulging out here around the glass. So you're putting pressure on the glass, not the greatest situation there. And when you got to take these off, you can have some trouble because they're very tight. So what tends to happen is it rips the tube out of the socket. And if the base happens to be loose, you can very well rip the glass out of the Bakelite base. So what I propose to do with this radio, since it's already wired up with pin 1 grounded, is to use these metal types. I have a bunch that I know are good, like these are new old stock. But I can put these shields on for appearance sake, and no problem. They're also more commonly available. These G-types didn't last too long. I think it was mainly Philco who used them, and you can see the troubles with the shields and not the greatest tube design. So I'm going to use model types for the 6K7, 6A8, and the 6Q7 like I just showed. In fact, I don't have any other 6Q7Gs around. The one I've been using I pulled out one of my radios. And the 6F6s, although there are metal types, I've got plenty of the GT types, so that's what I'll use for those. Oh, and should mention that the older Philco radios used round shields. And even the earlier square shields seemed to be a bit roomier. When I was doing my 3810, 38.7 chairside, I don't recall the tube shields being that tight around the tubes. This may look like a mess, but I've actually got a pretty good handle on things, I think. Between the reference photos and the schematic and studying the existing wiring and components, pretty well got everything figured out. Got the tube sockets all wired up, and I know what these wires should go to. Some of these old wires I figured out too. These three actually go to the antenna terminals. Black, red, black, and ground. And because these all look the same, you can't tell the colors anymore, I'm going to remove these and use some replica cloth covered wire, red and black, and I'll use brown, I guess, for the ground. Alright, for some of the others I used more modern wiring just because it was more convenient. So for example, this yellow guy is power for this section. That is what goes to that 16 microfarad cap there. So one of these wires will go to the capacitor that gets mounted up over here by the tubes, and the other one goes off to the power supply chassis. These three, as I mentioned before, go to the grounding straps on the tuning cap, and these three go to the actual variable part of the capacitor, which leaves a few other wires that are going to sections on the switches in here. So I wanted to make sure everything was right, so I buckled down and deciphered the switches. Oh, by the way, this schematic, this is one I found online. It's sort of an enhanced version of the riders. This is the riders. And this is very close to the Philco service bulletin that I have, which is this guy here. But it's subtly different. Remember, I found a extra winding inside one of the first IF transformer. Well, somebody wrote this in. I don't know who did it or when they did it, but they X'd this out and they put in a squiggly going to ground, which is exactly what I found. Other changes, it seems like they went through and cleaned up some of the letters and numbers, so it's a little bit clearer, which is nice, because on these switches things get a little hairy. It's nicer to read this copy rather than this copy. So, only one little problem that's cropped up so far. So these decks, switch decks, are labeled A through F. A starting from the back. A, B, C, D, E, F. And I finally figured out the orientation. So this is number one. Looking at it this way. Fortunately, they don't have it that way in the schematic. You got to kind of rotate things around. So if you look at the A deck, A1 is this guy right here. So that's how I was able to figure out these are the antennas. Because if you go A1, A2, A3, A4, and A5. Two of these wires are going to A4 and A5. And if you look on the schematic and find A4, that's going to red. A5 going to black. Now notice that you have multiple A5s. that's what makes this extra confusing. Why? How can there be 3 A5s when there's only one A5 lug? Well, that all comes down to the actual switching elements. There's some on both sides. So A5, 1, 2, 3, 4, 5 goes through to here. Actually, this one doesn't go on both sides, but some of them do. Some of them do, which makes it confusing. But how that can go to more than one thing, well, remember this is only a 3-position switch. 1, 2, 3. But we have far more than 3 terminals going around here. So these are actually sort of grouped into sections. And so 5 is going to that center element, which wraps all the way around. And then there's various elements going all around that. So that can actually, as you rotate it, there's groups of 3 of these that come into play as you go around. 12 altogether, so there's like 4 sections of 3 contacts. So that's why we can have multiple things going to A5, for example. Alright, so I saw the antenna wires, they make sense. Likewise, the rest of this makes sense until I got to this guy. I was trying to figure out what did this wire go to. This guy right here. Well, it's going down to this terminal right here. So this is the D deck, and that's position 1, 2, 3, 4, 5, 6. Alright, D6. Well, try as I might, I can't find a D6 on here. But there's certainly a D4, and that goes to a bus that goes off to another chassis. So, you would expect there to be a wire, certainly going to D4. Here's the problem. D4, no evidence there's ever been a wire going to that. Okay, well, most logical conclusion I could draw as well. Maybe there's a mistake on the schematic or a production change, and really D4 is D6. Well, going on that assumption, I've been trying to verify that. So I hooked up, for example, an ohm meter between D4 and D7, and in all 3 positions I get basically a dead short. However, for D8, should be a dead short for 2 positions and open on the 3rd, but I'm getting what appears to be a dead short in all 3 positions. So I don't quite know what's going on there. So what I'd like to do is examine it. Now on this side of the switch deck, it's pretty easy to see. So visually I was able to verify some of the switch operations as well, because you can see the metallic elements coming and going. And even the ones on the other side, you can kind of peer through the slots in there and see how they make contact. But what I really need to see is this side. Fortunately, that's against a piece of metal. So these sections come apart, not so much now because I've wired some of this stuff together, but I could slide them off of the shaft and I could bend things around. But the only way you can really see this deck well is to disconnect the stuff that's attached to it. So I have to take off all these nuts. Well, I'm going to give it a brief attempt. Because here's the other thing. Look where that D4 goes. Follow over to the left, it goes to B4, which is this resistor right here, and that's B4 right there. And the way this was wired, there's a resistor here, and there was already a wire coming off of here. So if this was originally connected to that and going to the same thing, why was there no jumper wire here? Or if there's a production change, fine. Okay, we're using this lug now. Why not connect these 2 together and have a single wire coming off? Why have 2 separate wires if they're going to the same place? That's what's got me a little puzzled. And if they are going to 2 different places, I have no idea how to figure out what that might be. So what are they going to on the schematic? Is that right? Is that... Yeah, it looks like that might be, AGC actually, or AVC rather. It goes to that 1 meg resistor. Down around. Over, which seems like something that's pretty important to get right. Or simplest thing to do is just hook it up in the way I think it's supposed to go and see if it works or not. I remove the switch shaft. Now I can separate these sections. And I want to take a look at what's on the other side of this plate. And I think it's going to be easier than I realized because I don't have to take out all of these. I think just these two. So there's one. And there's the other. So this, it's attached to those trimmer caps underneath. Maybe I can bend it enough and I can see what's going on. Still a little bit obscured because of this frame here, but I could definitely see in there better now. I think I can figure things out. Let's see. Grab the shaft again. Door is just through this section. There's a little nub, by the way, on the end of the shaft. That's how you can line things up. So I can rotate the switch now. Alright, so I'm going to study the diagram and see those various bits of metal are making and breaking contact and see if it makes sense. Well, once I finally got some light down in there and studied things, yes, it does indeed make sense. I think it's easiest to see on this lug over here, which is 7, 8, 9, 10. So that guy right down there. So if you look on the schematic, for 10, going to D4, it should be shorted on the outer two positions, but not the middle position. So right now it is shorted. I'm trying to rotate this shaft so you guys can see that, but there is right now a little piece of metal right there making switch contact. And I go to the second position and no piece of metal there. And now I go to the third position and once again it is making contact. Same goes for the other positions that I've studied as well, so I think that is indeed where they used D6 instead of D4. Alright, so let's slap this all back together and proceed